In this extra problem, we're asked to find the domain of the function fx comma y is equal to the square root of 2x plus 3y plus 6. When you're asking about the domain, you're asking what are the possible x comma y combinations that I can plug in to this expression to get a valid thing out of this computation. Since we're working with the square root structure, we need the stuff going into the square root to be either a positive number or 0. So the x's and the y's that we're allowed to use are the x's and y's that satisfy 2x plus 3y plus 6 being either greater than 0 or equal to 0. We can make quick work of this inequality by keeping the variables on one side, so far so good, and taking the constant and moving it over to the other side. Consider what the graph will look like for 2x plus 3y equal to negative 6. If you had 2x plus 3y equal to negative 6, this is the equation of a line, and you can quickly determine what that line will look like by first considering the x to be out of the picture and solving 3y is equal to negative 6. This will give you that y is equal to negative 2. So you would have that point right there at 0 comma negative 2. And on the flip side, what if y was equal to 0? You would solve 2x equal to negative 6, so x equal to negative 3. And the line that connects these 2 points is the line of 2x plus 3y is equal to negative 6. So once we have this line, we can first ask ourselves, are we going to use this line as part of our solution? Because we have an equal sign down here, we will use the points on that line. So these points on this line will be part of our domain. And now consider that this line has partitioned off this collection of points into 2 pieces. This piece on the lower left-hand side and this piece on the upper right-hand side. So your solution is going to be either all of the points down here or all the points up there, but not both. What you can do is select a test point from either this region down here or that region up there and plug it into this inequality and see if it works. If it does work, then that point and its region are part of the solution. If it doesn't, then it's the other region that is the solution. Can you give me a point up here somewhere that might be convenient to plug in? You can plug in 0, 0 if you like, right? That's an easy one to plug in. When you plug in 0, 0 into the left-hand side of our computation here, is this a valid inequality? On the left-hand side, we'll have 0. Is 0 greater than or equal to negative 6? Sure is. So since this point is valid, then all of the other points in that region are going to be valid as well. So this collection of x's and y's on the xy plane are part of the domain of your function f of x comma y. In example 3, we explore more examples asking for the domain of a function. For part A, we're looking at the domain of the function fxy is equal to the square root of x plus y plus 1 divided by x minus 1. And this looks very similar to what we had before because you have a square root involved. So you would ask yourself, when is x plus y plus 1 greater than or equal to 0? Again, you can move the constant over to the right-hand side and consider the line of x plus y equal to negative 1 and get things going from there. So if you were to block out the y's, you have that x is equal to negative 1. If you were to block out the x's, you would have that y is equal to negative 1. So you would have negative 1 here, negative 1 there, and x plus y is equal to negative 1 would be this line down here. So because you have this equal sign down here, you will be using these points down there. And now you have to ask yourself whether you will be including the points below that line or the points above that line. Again, you can select a test point. Conveniently, again, we have 0, 0, but you can select any other point. Let's say, so that we don't get too comfortable with 0, 0, let's plug in 1, 1. If you plug in 1, 1 into your x's and y's here, does it give you a valid inequality? Well, 1 plus 1, is that greater than or equal to negative 1? Is 2 greater than or equal to negative 1? Sure is. So this point 1, 1 will be part of our solution, and so will all of the other points on that top part, on that top region. Now we got to be careful because there's a little bit more detail to consider. We also have this condition that our function is being divided by x minus 1. So here you cannot let x equal to positive 1. In particular, any point that lives along this vertical line has an x value of positive 1. So all of these points must be omitted. They must be deleted. So ultimately, when considering what points are included in my solution, I can start by looking at the points that live either on this line or this line. Again, because I can't use any of these points with an x coordinate of 1, I know that I'm not using these points here. For the points along our line, I will be using these points on the left-hand side. I will be using these points on the right-hand side, but I cannot use this point where those guys intersect. And when considering whether I'm using these 4 regions, the bottom left, top right, and bottom right, I can go one step at a time and consider if these regions are included in my diagram here. The bottom left is definitely not included. I'll be omitting that out. The top left is included. The top right is included. And what about the bottom right? What about this region down here? That region is not included. So ultimately, my domain consists of all of these points in this region and all of those points in that region. Another structure that has some limitations in the domain is the natural log structure, and part B gives us that structure to look into. When considering what x's and y's you can plug into this function, because you're working with a natural log, it might be a good idea to consider what the graph of the regular old natural log looks like. Your natural log function looks like this, where its domain is everything from 0 off to infinity. So whenever you're working with a natural log function, your domain is only the positive numbers. So the things that can go into this natural log have to be specifically greater than 0. Not equal to 0 anymore, like when we had with the square root. So here you can move things around. This sort of looks like a parabola, except that this would be a parabola in y. So if I move the x over to the right hand side, I'll have this, and I'm gonna flip these guys and have this inequality to get a better perspective of things. Whenever you have a parabola in y, this is a parabola that opens either to the right or to the left. Because this guy has a positive coefficient, it'll be a parabola opening to the right. When considering whether I'm going to use this graph as part of my solution, I look at this guy and see that it doesn't have the equal sign on the bottom. So the points along this curve are not going to be used. And again, we have to consider two regions to include for our solution, either the region on the left-hand side made up of all of these points, or the region 2 on the right-hand side made up of all of these points. As before, you can take a test point from one of these regions and plug it into our inequality and see which one works. You have a whole bunch of different combinations to use. How's about we use this point right here with coordinates of 1, 0. When I plug in zeros in for my y's and ones in for my x's, do I get something that's greater than 0? On the left hand side I have 1 greater than 0, and in fact that's an inequality that works. So I will be using all of the points to the right hand side of this parabola as my domain.